Hi everyone, today we're going to do the notes for lesson 3.7, which is modeling linear inequalities. The top of the notes has the success criteria for today, so by the time the lesson's done, you want to be able to create and write inequalities in two variables that model a real world scenario. You want to be able to use those inequalities that you create to substitute a given value in for one of the variables to solve for the other, and you also want to be able to interpret the meaning of the solution set. So the notes today start out with a couple of examples to review what we covered in lesson 3.6. The first one here wants us to graph the inequality y is greater than negative 3x plus 2. And so we're going to go through and graph this inequality. Remember that the y-intercept is the b value, and so we're going to start this graph right here at positive 2. And then remember that the slope is the number that is in front of the x, and so we're going to graph the slope for this line. So we're going to go down 3 and 1 to the right, down 3 and 1 to the right, down 3 and 1 to the right, and then we can also go back to the y-intercept, and we can do opposite. So we can go up and to the left to get one more point on the graph. The type of inequality symbol will tell you what kind of line to draw and which direction to shade. And so for this graph, it's a greater than symbol, and so that means that we're going to shade above the line. And then because it's a greater than symbol and not a greater than or equal to symbol, it means that the line that we draw on the graph is going to be a dashed line. And so remember, when you draw a dashed line, you're going to pick your pencil up and put it down. So your line's going to have spaces in between it. Still has arrows on both sides to indicate that it keeps going. And then for this one, we're going to shade above the line, which means we're going to shade up from the line. And so on this one, it means we're shading up here. You can always pick and plug in a test point to make sure you shaded the right side of the graph. And so there you go. That's y is greater than negative 3x plus 2. In the next example, we're going to follow the same process. And so the b value is right here at the end. So we're going to start this graph down here at negative 4. That's the first point we'll plot. And then the slope is the number in front of the x. So for this one, we're going to go up 1 and 2 to the right, up 1 and 2 to the right. And then we'll go back to the middle point on our graph, and we'll go down 1 and 2 to the left. And so we can continue the graph over here in this direction. And then the same as last time, the type of inequality symbol is going to tell us which way to shade and what kind of line to draw. So this one's less than or equal to, so that means that when I'm done graphing it, I'm going to shade below the line. And then because it has the or equal to line, that means that the line that I draw is going to be a solid line that I draw on the graph. So use straight edge, arrows on both sides to indicate that the line keeps going. And then you guys, for this one, we're going to shade under the line because it's less than or equal to, so we'll shade down here. And so that's the graph for this one. This is y is less than or equal to 1/2 x take away 4. Example 3 and 4 are the flip of what we practiced up above. So on these ones, the graph's already graphed, and so we just have to find the 4 things that we need to figure out for each graph. On this one, it crosses the y-axis at negative 2, and so that means that the y-intercept is going to be minus 2. And then we're going to count the slope, which means going through and finding points that are on the graph. It looks like there's another point right here. And it looks like there would be another point up here. And so we can count the slope. To get from one point to the other, you're going to count up 1, 2, 3, 4, 5, and then over 2. And so on this one, the slope is 5 over 2. Remember that we're writing an inequality, which means that the y is going to go first on these ones. And then the last things that we have to figure out are the type and direction of the inequality symbol. So we still need to fill in that yellow space. On this one, it's a dashed line, so it's not going to have the or equals to line underneath it. And then because we shaded above the line, that will help us decide that it's a greater than symbol. And so the inequality that's graphed here is y is greater than 5 over 2x minus 2. In this last review, example number 4, we'll do the same thing. So this graph starts up here at positive 6, so that means that our y-intercept is going to be plus 6. And then on this one, we want to find the points that are on the graph. So it looks like there's a point here and a point here. We're looking for places that the line crosses a whole number coordinate points. So for this one, I'm going down 1, 2, 3, 4, and then I'm going 3 to the right. So my slope for this one is going to be negative 4 over 3. My slope goes in front of my x. These inequalities can all start with a y. And then the last thing I have to figure out on this one is what kind of symbol goes here. On this one, it's shaded under the graph, so it's going to be less than. And then because the line is solid, it's going to have or equal to, so it'll have the line underneath. And so that's the answer for this one. Y is less than or equal to negative 4/3 x plus 6. So one of the objectives in the notes for today is that we want to be able to read and interpret word problems, and then we're going to model them using inequalities. And so we're going to be looking for words in the problem that mean the different symbols in math. Today, most of the representations that we come up with are going to be able to be represented with inequalities. So either a greater than symbol, a greater than or equal to symbol, a less than symbol, or a less than or equal to symbol. And so these phrases over here in the left-hand column are going to help you see which one you're going to use. If you see that something has to be greater than something or more than something, you'll use a greater than symbol. If you see phrases that talk about something being a minimum of something else or at least something else, then that's typically going to be greater than or equal to. Anything that says less than will be a less than symbol. And then if you see anything that's phrased as being a maximum of something or not more than something else, then that's going to be a less than or equal to symbol. Moving on to example 5, these are what the notes today cover. So we're going to read the words about what's happening. We're going to create an inequality that models what's going on in the problem. And then after we're done with that, we're going to use the inequality that we made to answer a subsequent question. David has 2 jobs. He earns $8 per hour babysitting his neighbor's children. And so this is one of the things that's happening in the problem. And then the other thing that's happening is it says that he earns $11 per hour working at the coffee shop. So each of his jobs has a different rate of pay. We're going to write an inequality to represent the number of hours X babysitting and the number of hours Y working at the coffee shop that he would need to work in order to earn a minimum of $200. And so that word minimum is going to be helpful when we create our inequality. Babysitting is going to be X, and then the coffee shop work is going to be Y. And so if we create an inequality that looks like this, 8 times the number of hours that he works babysitting plus 11 times the number of hours that he works in the coffee shop, for David to earn a minimum of $200, that means that David wants to earn equal to $200 or greater than $200. And so that's how we would pick that inequality symbol. So this inequality represents correctly his rate of earning and also the number of hours that he would need to work at each job in order to make $200. There are lots of combinations of hours that would make this problem be true. In part B, it says that David worked 15 hours at the coffee shop. And so when we solve this problem, we're going to take the inequality that we came up with in part A and we're going to plug in 15 for Y because Y represents his hours working at the coffee shop. We want to figure out how many full hours he has to babysit in order to reach his goal of making at least $200. So 8 times the number of hours that he has to babysit plus 11 times the 15 hours that he works at the coffee shop. We want to solve this to figure out what's the least number of hours that he can babysit in order to reach that goal. So grabbing our calculator, 11 times 15 is 165. So this turns into 8x plus 165 is greater than or equal to 200. And then we're going to solve this for x. So we're going to minus the 165 from both sides. And then we'll finish by dividing by 8. You guys, it's important to note on this one that you're not going to get a whole number answer. And so the way that we round the problem is going to be specific to the directions that the question gave us. When I do 35 divided by 8, I get 4.375. And so if he works only 4 hours babysitting, he wouldn't make enough money to reach his goal of making $200. And so this answer right here means that the answer to the question is 5 hours. He would have to work that 5th hour. He would end up making a little bit more than $200, but working that 5th hour would bring him above his goal of making $200. So you guys, number 6 is a similar question. It says that Matt and his friends are going to visit the concession stand at the Padres game, and there's also 2 things happening in this one. So it says that they sell beverages for $5, and then the second thing is it says that they sell hamburgers for $9. So those are the 2 things that are going on in this question. We're going to write an inequality to represent the number of drinks X and the number of hamburgers Y at the Padres game that they can buy if they want to spend at most $60. And so that phrase is important because that will help us figure out the direction of the inequality symbol. If we're going to let drinks be X and then we'll let hamburgers be Y, for this one, when we set up the inequality, it's going to be $5 times the number of drinks that they buy plus $9 times the number of hamburgers that they buy. If they want to spend at most $60, then that means that they want to spend either equal to $60 or less than $60 because $60 is the maximum that they want to spend. So that phrase at most is what helps you figure out the direction of that inequality symbol. Part B says that if they purchased 4 drinks, and so we want to make sure that we're putting it in the right spot. Drinks is our X variable. We're going to use the inequality to find the maximum number of hamburgers that they can purchase. And again, you can only buy a whole hamburger, so we'll keep that in mind. So 5 times the 4 drinks that they bought plus 9 times the number of hamburgers that they can buy, and they want it to be less than or equal to $60 because $60 is the most that they want to spend. And so we'll go through and we'll solve this for y. 5 times 4 gives us 20. And then we'll minus the 20 from both sides. We'll get 9y is less than or equal to 40. And so you guys, on this one, same thing. We're not going to get a whole number as our answer to this question. We're going to end up getting a decimal, and then we're going to have to interpret that decimal. So I'm going to get y has to be less than or equal to 4.4, repeating 4.44444. But then we need to think about what that means in terms of hamburgers. On this one, if they bought 5 hamburgers, they would technically spend too much money based on what they want to spend. And so the answer for this one is that they can buy a maximum of 4 hamburgers if they want to stay under their goal of not spending more than $60. So sometimes you have to round up and sometimes you have to round down, and it just depends on the question and whether it's a maximum or a minimum that you're trying to meet or stay within. All right, the last example on today's notes is one more modeling problem. It says you're making fruit baskets and you can spend at most $20 on fruit. And so that phrased at most will help us figure out the inequality symbol. It costs $2 for each apple and $1 for each orange. So we're going to start out by writing an inequality that represents what's going on. So if it's $2 for each apple, and then it says $1 for each orange. And so we're going to use X to represent apples, and then we'll use Y to represent oranges. And so we'll start by writing an inequality. So $2 for each apple plus, and then you can put the 1 here if you want to for each orange, but you can also erase that 1. You don't need to write it there. And if you're spending at most $20 on fruit, that means that with regard to filling in the inequality symbol right here, you want to spend less than or equal to $20 because $20 is the maximum that you want to spend. The way that we're going to complete this table is by plugging in the values for X and for Y. And so remember from the problem up above, X was for apples and then Y was for oranges. And so we'll label them here so that we don't get them mixed up. So you guys, one at a time, we're going to plug in each of these numbers for the letter that it represents. You can do this underneath the box. You just might want to write a little bit smaller than you normally do. So 2 times plug in the 4 for the X plus 1Y is less than or equal to 20. When I solve this problem right here, that's going to give me the answer for how many oranges I could buy if I bought 4 apples. And so I'll minus the 8 from both sides. And so the answer for this question right here is 12. If I bought 4 apples, then I could buy anywhere up to 12 oranges, but I couldn't buy any more than 12 oranges because that would exceed my goal for what I want to spend. On the next one, we want to figure out how many apples I could buy if I don't buy any oranges at all. So 2x plus, and then we're going to put the 0 in for the y. And so on this one, we want to go through and solve to figure out how many apples you could buy if you don't buy any oranges at all. And so on this one, I'll divide both sides by 2. And I'll get x is less than or equal to 10. And so 10 is the number that fills in on that table there. 10 is the total number of apples I could buy if I don't buy any oranges and still stick within my goal of only spending $20. On the next one, we're going to do the opposite. We're going to figure out how many oranges we could buy if we don't buy any apples. And so for this one, we're plugging in 0 again, but we're plugging it in for the x, not the y. And so on this one, if all I buy is oranges and they cost $1 a piece, then I could buy 20 oranges and I could still stay within my goal. And then one more time, we're going to figure out how many apples we can buy if we buy 14 oranges. So on this one, the 14 gets plugged in for the y because y represents oranges. And then we'll go through and solve this one. We'll minus the 14 from both sides. And then we'll finish by dividing both sides by 2. And so on this one, we get that if you buy 14 oranges, you can buy anything less than or equal to 3 apples in order to stay within your goal. The second part of the question wants us to graph it, and so in order to graph it, we're going to graph the 4 points that we generated. So 4 goes with 12, so that's one possibility. And then 10 goes with 0, so that's another possible combination. 0 goes with 20, and then the last point that we generated was that 3 went with 14. And so you guys, this graph has the points for the 4 possibilities that we generated, that we came up with. In order to figure out what to do with the rest of the line, we're going to look at these 2 points that are right here. We're not going to draw the line between them. We're just going to talk about them. On our graph, our x-axis represents x. So this is the number of apples that we're buying. And then our y-axis represents oranges. And so on this side, this is the number of oranges that we're buying. And so it looks like, if you go back to that part that I highlighted in yellow, for every one more apple that you buy, it looks like you have $2 less to buy oranges, so you can buy 2 less oranges. So what we're going to do now is I'm going to erase the highlighting on the graph because we're not going to highlight that part, but we're going to go in and fill in the other points that we didn't generate for our table. So if you buy 1 apple, you can buy 18 oranges. If you buy 2 apples, you can buy 16 oranges. And so it looks like the slope of this line is -2, and so we're continuing the pattern. The reason why it's important on this one to continue the pattern is because this is a discrete data set. You can't buy half an apple. And so I want you to make a note on this one that we're not going to draw the line because it's discrete. The directions in the question remind us that we need to shade, and so now we're going to shade on our graph. The inequality was less than or equal to. We're not going to draw the line. It would be a solid line, but we're not going to draw it because it's a discrete data set. But now I need to shade. In order for them to spend less than or equal to $20, the line of points represents the maximum amount of fruit that they can buy, but we're going to shade under the line because although they wouldn't be spending all of their available money, they could spend less than $20, and that would still meet the criteria for the question of not exceeding $20. So that's why on this one you shade under the line. Part C on this problem says, given the constraints, name 3 possible combinations of apples and oranges you can buy that are not on the line. And so when it says the constraints, it means that you're going to spend less than or equal to $20. And so the answer to part C would be any combination of points that you want to pick that's in the shaded part. So any combination that's in the shaded part of the graph. And so you can just pick 3 possibilities, like totally random. But for example, if you bought 4 apples and if you bought 8 oranges, then that would be one possibility. So 4,8 would be one possibility. What else? If you bought 1 apple and if you bought 13 oranges, that would be another possibility. That's a yes, because it's in the shaded part of the graph. And then last one is if you bought 7 apples and if you bought 3 oranges, then that would also be fine because that's also in the shaded part of the graph. So it's any answers that are in the shaded part. The ones that I picked here are just super random. The last question on today's note says to name 3 combinations that are not possible. So these are no possibilities. These are possibilities that would result in them spending too much money. And so the easiest way to understand this question is just to pick 3 points that are over here that are in the not shaded part. So any combination in the not shaded part of the graph. And so it can literally be anything. You can pick silly answers too. So for example, if you bought 8 apples and if you bought 19 oranges, 8,19 would be a no because that would result in them spending more than they're hoping to spend. If you bought 5 apples and 13 oranges, that one would be over here and that would be a no. So 5,13 would also be a no. And then just picking one more, if you bought 9 apples and 7 oranges, that one down here would be a no. And again, these are just random answers that I'm selecting. But any combination that is in the shaded part is a yes, and then any combination of points that is not in the shaded part of the graph is a no when it comes to coming up with possibilities.